We tend to think of AI as pure logic, right? Just cold, hard data making decisions. But what happens when that data, and the people who build these systems, have their own hidden prejudices? See, these AI systems aren't just inheriting our biases, they're actually amplifying them. And that can lead to some seriously flawed decisions with massive real-world consequences.
And let's be clear, this isn't just some technical glitch we're talking about. Bias in AI has a profound real-world impact. It can literally determine who gets a loan, who gets a job interview, or even who gets flagged as a potential criminal. This stuff fundamentally affects people's lives, and, it really erodes our trust in the technology that's supposed to be making things better for all of us.
So, that brings us to the big question for this whole explainer. How does this bias actually sneak inside the so-called black box of AI? Turns out, it's not just one single mistake. It's more like a series of vulnerabilities all along the entire process.
Okay, so the journey begins right at the starting gate, with the AI's food, the data it learns from. And that old saying is truer than ever here. Bias in, bias out. I mean, if the raw information is flawed from the very beginning, the final outcome is pretty much destined to be flawed too.
The first major pitfall is something called collection bias. This is what happens when the data we feed the machine is skewed, when it just doesn't reflect the reality of the world it's supposed to be working in.
So, for example, if you train facial recognition software mostly on pictures of people from one ethnic group, it's going to consistently fail to recognize people from others. Or think about crime data that overrepresents certain neighborhoods because of historical policing patterns, not because more crime actually happens there. The AI learns that flawed pattern and just keeps it going. It's the same exact thing with health data that's focused on common diseases, making rare conditions practically invisible to the system.
But here's the thing, even if you manage to get perfectly representative data, another problem can pop right up: annotation bias. This happens when the humans who are labeling the data, the ones telling the AI what it's looking at, unintentionally inject their own unconscious judgments right into the process.
What this means is that an annotator's personal worldview can get embedded directly into the AI's logic. Just imagine a hiring tool. If the people labeling resumes as successful unconsciously favor candidates from, say, their own university, the AI learns that this is the only sign of a good candidate, and pretty soon it starts filtering out everybody else.
All right, so let's move on to the next stage and see how this all builds up. Because even with perfect data, believe it or not, the very design of the algorithm, the code itself, can create its own forms of bias and exclusion.
This brings us to what's called selection bias. This happens when a model has a total blind spot for a specific group just because it hasn't seen enough examples in its training data. So the model doesn't really know what to do, and it ends up making an unfair guess.
Here's a perfect example. A bank might train a loan approval model on decades of data from people who live in big cities. Now, when someone from a rural area applies for a loan, the model might just reject them. Not because they're a bad credit risk, but simply because their financial profile looks unfamiliar. The algorithm ends up confusing different with risky.
And this is not theoretical at all. A real financial institution found its credit scoring tool was unfairly rejecting immigrants and first-time loan applicants. Things like their social ties and where they lived were being used as unfair filters. But here's the hopeful part. After they audited the system and changed the rules, they actually expanded credit access to these groups, pushing back on the algorithm's unfair assumptions.
Now, let's zoom out a bit. Beyond the data and the code, there's the human element. The cognitive biases of the very people who design, build, and use these AI systems, well, they're a huge source of error. You could call it the ghost in the machine.
Let's look at two key human errors here. On the left, we've got confirmation bias. This is the creator's error. An engineer might believe that older workers are less productive, and so they unconsciously build a model that favors younger candidates. Then on the right, you've got automation bias, and this is the user's error. This is when a human reviewer sees an AI-generated reject flag and just clicks approve, totally trusting the machine without doing their own due diligence.
And at the end of the day, AI just learns from our history. So all those long-standing societal inequalities, like unequal access to good schools or housing, they get baked right into the historical data. And unless we actively work to counteract this, the algorithm will simply learn these patterns and perpetuate them, creating this awful cycle of exclusion.
Okay, so we've diagnosed the problem from a bunch of different angles, but what do we do about it? Well, the good news is there are concrete, actionable plans for building fairness directly into the process. It's really about having a better blueprint.
This mitigation workflow really shows an end-to-end process. First, you pre-process the raw data. Then, during what's called in-processing, you build fairness goals directly into the algorithm while it's training. Next, you post-process the final outputs to make sure they're equitable. And crucially, you monitor the system continuously after it's live, because bias can always creep back in.
And to make this workflow a reality, teams can use a tool just like this Lifecycle audit template. This isn't just a suggestion, it's a concrete checklist. At each stage, like data collection, there's a specific bias check, like a representation scan, and a key metric to measure, like group coverage. This builds accountability and vigilance into every single step of building and maintaining an AI.
So we're left with this final, really crucial question. AI is a mirror. It reflects the data we give it, and that includes our entire messy and often biased history. So fixing AI isn't just a technical challenge, it's a societal one. It forces us all to confront our own blind spots and to decide intentionally what kind of world we actually want our technology to build.